This is the Algebra 1 semester exam review for the spring semester. And this is a little bit long, so I'm going to go through these pretty quickly, but I should cover the whole thing. So the first section is dealing with exponential expressions using exponential properties. I want to remind you that those rules are on your formula chart, okay? I'll go through them really quickly. When you're multiplying terms that have exponents and they have the same base, you're adding those exponents. When you're dividing the same base, you are subtracting the exponents. When you have a power to a power, meaning you have an exponent on some parentheses outside, that exponent applies to everything inside the parentheses, and what you do with the exponents is you multiply them. When you have a power, a base raised to a power that is a fraction, we call that the tree that falls down. It's the same thing as this. The tree goes timber. Here's my tree. He falls over. The top number goes over to the right inside the radical. The bottom number stays where it is, and he's on the outside of the radical. Now I want to point out that n is not out here in front being multiplied by the radical. That n is telling you about the radical. Like if that n is a 3, it's a cube root. If the n is a 2, it's a square root, and so on. It's not out in front. It's right there in the box. On the calculator, when you do that one, you're doing the Control caret top button. Okay? It gives you that little n to the x radical. And then lastly, negative exponents, we get rid of them. The first thing we do, if it's upstairs and it's negative, you move it downstairs and make it positive. If it's already downstairs and it's negative, you move it upstairs to make it positive. If you see a negative exponent, that's the first thing you need to do on your problem is get rid of the negative exponents. So I'm going to zoom in a little bit so you can see this review a little better. And we'll get started on that first section, exponential expressions. So, number one, and guys, you're going to have to do this on separate paper, especially if you are some people we've spoken with about turning this in for some missing work replacement. You're going to have to do it on separate paper, all right? Okay, so simplify each exponential expression using exponential properties. So I'm multiplying the same base, so I add the exponents. That's going to be, number one is x to the 10th, because 6 plus 4 is 10. All right, number two, I'm multiplying all this stuff, so I look first to the coefficients, the numbers in front. This one doesn't have one, so it's an invisible 1. This one is 2. So the invisible 1 times the 2 gives me 2. And this is number 4, by the way. I'm doing it because of the paper I have. I'll go in this order. Okay, so that gives me 2 in front. And now look at my x bases. I have an x to the power of 2, and x to the power of invisible 1. 2 plus 1 gives me x to the 3rd. Now, I've taken care of my x's, I took care of my 2. All I have left is y. Y to the 4th and y to the 2nd gives me y to the 6th power. That's all there is to it. So 2, x to the 3rd, y to the 6th. Let's do number 7. Now notice something, the 4 is in front. It is not being affected by this exponent 5. Okay, the exponent 5 is affecting everything in the parentheses. And I have to do that first before I do anything with the 4. Okay? So I am multiplying. It's power to a power. X squared to the raised to the 5th is x to the 10th. And then y to the 6th raised to the 5th is y to the 30th. And that entire thing is multiplied with by the 4 in front, so I end up with 4 x to the 10th, y to the 30th. That's it. Okay, let's take a look at the next 3. I'm going to be doing number 2, 5, and 8. Okay, so number 2, we have 5x to the 5th, but it's all raised to the power of 2. Now, unlike the last one we did, this 5 is in the parentheses, so it is affected by that power of 2. This is not 5 times 2, it's 5 to the second power, which is 5 times 5. So that gives me 25. And then x to the 5th raised to the power of 2, that is when you do 5 times 2, because they're exponents. We use the exponent rules. 5 times 2 is 10, we have x to the 10th power. So number 2 is 25x to the 10th power. Okay, now number 5, I'm going to have a few steps here. If you take a look at it, we have a negative exponent downstairs. We also have a power of 0. Now, power of 0 is not on the reference materials paper. I didn't talk about it. Basically, anything to the power of 0 is 1. So that z to the power of 0 becomes 1. Anything times 1 is itself. So you can basically, in essence, cross it out. It just goes away because it's anything times 1, you just get this. Now, this x to the negative 4 has to go upstairs and become x to the positive 4 upstairs. There he is. So he's no longer downstairs. So now I have 24, a y to the 6th, and an x to the 4th. On the bottom I have 8y. Or is that y squared? It's hard to see this thing. Nope, I crossed that one out. It's 8y. So I'm going to take care of my 24 and my 8. That's just 24 divided by 8. 24 divided by 8 is 3. Okay, now I have my y to the 6th, and downstairs I have my y. So we do subtraction there, and 6 minus 1 is 5. So we have y to the 5th. Now I'm going to put this here because I'm doing this in alphabetical order, and my x is going to be here. I have x to the 4th, which I already took care of. He goes right here in the middle. So I end up with 3x to the 4th, y to the 5th. Number 8, we have 21x to the negative 8, y to the 5th. On the bottom we have 7x to the negative 2, y to the 3rd. So what I'm going to do, I'm going to rewrite the whole problem and flip those negative exponents. Okay, so I'm going to put 21, I'm going to go ahead and write my long fraction bar. I'm going to write the 21, but I'm going to write my x to the negative 8 downstairs, x to the positive 8. All right? I am going to write the 7 downstairs, but instead of that x to the negative 2 downstairs, I'm going to write x to the positive 2 upstairs. All right? And all I have left is my y to the 5th on top, my y to the 3rd on bottom. Okay, so now we just have 3 little math problems. The 21 divided by 7, and then deal with my x's, deal with my y's. 21 divided by 7 is 3. It's going to be 3 on top because the 21 was on top, the bigger number. Now here, I'm doing subtraction. That's the rule I covered earlier. But where do I have more x's? On the bottom. So I do 8 minus 2 to get 6, but it's x to the 6th on the bottom. Here I have more y's on top, so I do 5 minus 3 to get 2, but it's y to the 2nd power on top. So my final answer for number 8 is 3 y to the 2nd power over x to the 6th power. Okay, number 3, 6, and 9. Let's do those now. All right, number 3, 6, and 9. So number 3, this is a lot more straightforward than the one we just did. Number 3, I have my exponent here on the outside of the parentheses. I have to do that first. I basically ignore this coefficient in the very front because he's not affected by that exponent. So I have that guy going here and here. So 3 to the power of 2, it's not 6, that's 3 times 3 and gives me 9. Okay, so I have a 9. And then x to the 8th power raised to the power of 2, that's going to be 8 times 2. That's the exponent rule. That gives me x to the 16th. Now that's not my answer. What I did is I ignored the 2 that was in front, but now I'm going to write that in. So I took care of the parentheses, and that's what I now have in parentheses. What I do now is I just distribute the 2. 2 times 9 is 18. So my final answer is 18x to the power of 16. All right, let's check out number 6. We have another negative exponent in this one. We have x to the third. He's on top, so I'm going to leave him on top. We have y to the fifth. He's on top. I'm going to leave him on top. But this x on bottom is to the negative 2. I'm going to move him to the top. He's now x to the positive 2. So if you look at that, we don't have a denominator anymore, so we don't have to write it. And my exponent rules that I covered earlier, when you're multiplying the same base, you add those exponents attached to that base. So 3 plus 2 is 5. So we end up with x to the fifth, y to the fifth. That's number 6. Okay, number 9. We have 4x squared raised to the power 2 times 2y all raised to the power 3 divided by 8y to the negative 6 power times x to the third power. All right? So this is going to be a few steps. I'll probably use quite a bit of this room here to make sure I take care of each step. So I'm going to go ahead and first get rid of my negative exponent. I'm not going to worry about writing anything else or doing any more math until I get rid of that y to the negative 6th power on the bottom. So I'm going to rewrite the problem. I have 4x squared all raised to the power of 2. And then I have 2y all raised to the power of 3. And then I have on bottom 8. But this y to the negative 6 is going away. He's going to be y to the positive 6. I'm just going to write him over here on the end. Okay, and I still have x to the third on the bottom. Okay, that's step 1. Step 2, I'm going to go ahead and take care of the exponents that are on the outside of the parenthesis. That's that power to a power rule. Okay, so 4 to the power of 2 is 16, right? It's 4 times 4. So that gives me 16. And then x squared raised to the power of 2, that's 2 times 2. That gives me x to the fourth. So this first little part became 16x to the fourth. Now here I have 2 raised to the power of 3. That is 2 times 2 times 2. 2 times 2 is 4, right? 4 times 2 is 8. So that gives me 8. And then I have y raised to the power of 3. So that gives me 8y to the third power. Lastly, I have that y to the 6th that I brought upstairs. I'm just going to write them again. Okay? And that's still all over 8x to the third. Okay? Now I'm going to go ahead and multiply coefficients that I can multiply. All right? So I have 16 times 8. Let's go ahead and plug that in. 16 times 8 gives me 128. All right? So these coefficients multiply, give me 128. Okay, now what else can I combine? This y to the third is multiplied by this y to the 6th. I can add those exponents. That's going to give me y to the 9th. So I have 128 from these two. I still have x to the 4th. And I have y to the 9th. That's just the top, right? The bottom of this problem is 8x to the third. These coefficients I can divide. I have my 128 still in the calculator. Divided by 8 gives me 16. So my final coefficient in the problem is 16. Then with my x's, I subtract these exponents. 4 minus 3 is 1. It's going to be on top because I have more x's on top. So I have 16x y to the 9th power. That was a pretty beefy problem. I don't think we'll have anything that beefy on the final exam, honestly, but it's a good one to try getting ready for the final. Okay, so we're going to go ahead and stop there, and we'll go to the next video for the next section.